Dear students, in this lecture we will discuss how to find out the solution of a differential equation. Last time we have discussed how to get the order and degree of the differential equation. So let us see now what is the meaning of solution of a differential equation. So see here, a function of the form y is equal to f of x plus c, which satisfies the given differential equation, is called the solution of the differential equation. Now there are two types of solution. One is general and second one is particular. Okay, now what is the meaning of general solution? A solution of the differential equation in which the number of arbitrary constants is equal to the order of differential equation is called a general solution. We will take one example so that you will get the clear idea about the general solution. And then next is particular solution. A solution of the differential equation which can be obtained from the general solution by giving particular values to the arbitrary constants is called a particular solution. Okay, so general solution and particular solution are the two types of the solution of a differential equation. Now from your exercise 8.1 there is a question included that, see here, in each of the following examples verify that the given function is a solution of the corresponding differential equation. Now see this chart. In this chart one column is of solution and another one is of differential equation. Now in the column of solution there is a function given to you, means for example number 1, suppose x into y is equal to log y plus k, where k is constant. This function is given, and differential equation is given y dash means dy by dx into bracket 1 minus xy is equal to y square. And what we have to check here, we have to check that given function is a solution of this differential equation or not. That we have to decide, or we have to show this, the function which is given in column number 1 is the solution of the given differential equation in the column number 2, like this. So see this chart, there is a column of solution and the corresponding differential equation is given to you. Now we will solve this, then you will get the clear idea about the solution of a differential equation. We have to verify that whether the given solution is the solution of the given differential equation. Okay, so let us see now. Now in that question, see the third example, that is very simple. Here y is equal to e raised to x is function given to you, and dy by dx is equal to y is the differential equation given to you, and we have to show that the y is equal to e raised to x is a solution of this differential equation. Okay, so see how will you solve this. First of all I will write given function. So here given function is y is equal to e raised to x. Now we have to verify that whether this is a solution of this given differential equation or not. So first of all we have to differentiate this given function with respect to x. Then what will you get? See here, differentiate with respect to x. Hence you will get dy by dx is equal to, see, derivative of y with respect to x is equal to, now derivative of e raised to x is e raised to x. Now if you modify this, then dy by dx as it is. Now in place of e raised to x you can put y, and hence by using the given function after differentiating with respect to x we get the differential equation here, that is dy by dx is equal to y. So you can say that, hence we can say that the given function is a solution of given differential equation. See, so see here how to solve this. First of all you differentiate with respect to x, so that by using that derivative or by using that step dy by dx is equal to e raised to x, we get dy by dx is equal to y, because e raised to x is y. So from that function, after differentiating, we get the differential equation. Hence mathematically you can say that given function is a solution of differential equation. Okay, now let us see another example. Here the function is given y is equal to 1 minus log x, and differential equation is given to you, that is x square into d square y upon dx square is equal to 1. Now we have to check it is the solution of this differential equation. So given function is y is equal to 1 minus log x. Now the differential equation is given is of order second order. Here second order derivative is involved, so d square y upon dx square is second order. So it is the order of the differential equation is 2. So we have to differentiate this function, given function, with respect to x. Okay, so differentiate with respect to x, then you will get dy by dx, that is equal to derivative of 1 is 0 minus derivative of log x is 1 upon x. But as the differential equation is given to you whose order is 2, you have to again differentiate this with respect to x. So differentiate with respect to x again. So we get d square y upon dx square, that is equal to, here it is minus 1 upon x, minus as it is, and derivative of 1 upon x is minus 1 upon x square. See here carefully, and hence we get it is minus minus plus 1 upon x square. So we get d square y upon dx square as 1 upon x square. Okay, see, since derivative of 1 upon x is minus 1 upon x square, and here there is a minus sign, so minus into minus, so it becomes plus. Now after getting the second order derivative, now consider the given differential equation, that is x square into d square y upon dx square is equal to 1. Now in that you have to take LHS, that is x square into d square y upon dx square. Now put the value of d square y upon dx square as 1 upon x square here. So it is 1 upon x square, and after cancelling you will get it is equal to x square and x square get cancelled, and hence you will get 1, and it is nothing but the RHS. That's why you can say that this function satisfies the given differential equation. So you can write given function is a solution of given differential equation, because after putting the value of d square y upon dx square we get the RHS, so it satisfies the equation. So you can say that the given function is a solution of differential equation. Okay, now let us see another example. Here the function is given y is equal to a into e raised to x plus b into e raised to minus x, where a and b are called as arbitrary constant, and the differential equation is given to you, that is d square y upon dx square is equal to y. So first of all I will write the given function, given that y is equal to a into e raised to x plus b into e raised to minus x. Now here also the differential equation which is given to you is of order 2. Okay, so we have to differentiate the given function with respect to x. So see the differentiation here, we get dy by dx. Now derivative of a into e raised to x, a as it is, derivative of e raised to x is e raised to x, plus b as it is. Now derivative of e raised to minus x is minus b e raised to minus x. Okay, now again we have to differentiate this with respect to x. So differentiate with respect to x, then what will you get here? We get the second order derivative, that is d square y upon dx square. Now again take the derivative of a into e raised to x, a as it is, derivative of e raised to x is e raised to x, then minus b as it is, derivative of e raised to minus x is again minus of e raised to minus x, so minus minus becomes plus, and we get b into e raised to minus x. Now after getting the second order derivative, we observe that this term a into e raised to x plus b into e raised to minus x is nothing but y. So here the internal adjustment is possible. After this internal adjustment or by replacement as a into e raised to x plus b into e raised to minus x as y, see here, we get the required differential equation. Okay, so either by substituting or by direct adjustment, if you get the differential equation, then you can say that given function is a solution of differential equation. So there are two ways to check the given function is a solution of the differential equation. One is what? After getting the derivative, means either first order or second order, if you adjust the term or if you replace the term in place of like this, in place of a into e raised to x plus b into e raised to minus x, we get y, and after putting the y we get the required differential equation. Then you can say that given function is a solution of differential equation. Or otherwise, if you take the LHS of the differential equation and put the value there and try to get the RHS, then also you can say that given function is a solution of a differential equation. Okay, see, in this case we have solved like that. We take the LHS here and just we put the value of d square y upon dx square here, and after putting that value we get the RHS, and hence we say that it is a solution of the given differential equation. Okay, so see how to check the given function as a solution of the differential equation. So try to solve this type of question from the given question number 2 of the exercise. Okay, thank you.